Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is another video on solving 3x3 systems, and we have just gone through a review of the types of systems of equations and also a review on solving systems of 3 equations and 3 unknowns. This topic, at least at our college, is not considered a review. So this topic that we're going into right now, at least if you're in college algebra, should be somewhat new. It's considered to be new if you're fresh out of an intermediate algebra course or an algebra 2 course. And this is when you have systems with an infinite number of solutions and how you can write those solutions. And the way we write the solutions is what's called parameterized form. I say parametrized, but I think it's parameterized. That's really bad. All right, English is supposedly my first language, but unfortunately I'm not that great with it. All right, so let's go ahead and just pretend that we're handed this system of equations and asked to solve. In this case, substitution or elimination, they're both perfectly fine methods to use, because if you look at this system, it's what we would call a semi-sparse system. In other words, it's got some holes in it. And generally speaking, when you have systems of equations with holes in them, in other words, missing variables in some of the equations, you can do substitution if you want to. You could or could not, doesn't really matter to me. I'm going to use elimination, mainly because that's just the knee-jerk reaction that I go for. All right, so I'm going to call these rows 1, row 2, and row 3. And I'll decide to kill off the variables z. And I only really need to do it once, because when you kill off z once, you can then use the second system, or the second equation there. Let me showcase that. This guy right here, that only involves x's and y's to find out what x and y are. Let me show you what I mean by that. So we're going to take row 1, which has that -2 on that z, and we're going to add to it twice row 3, because it has a single z, and if I multiply it by 2, it'll be opposite signs. When you add those two up, you get the following. 0x plus a -2x is going to give us a -2x. Don't forget, you're multiplying that row 3 by 2. Then you have 1y plus a -4y. So in other words, -4y plus 1y is a -3y. -2z plus 2z, well, they cancel beautifully. And then finally, 0 plus a -2 will give me a -2. Once you get to there, or that point, I should say, then you can go ahead and grab another equation that only has x's and y's. And if you look at this equation right here, that's the other equation that only has x's and y's. So you could totally grab that equation. So our new system is now the system -2x minus 3y is equal to a -2, and a positive 2x plus 3y, whoops, that's supposed to be a 3, is equal to positive 2. Well, here's the problem. These are the same equations. And if you were to add them up, let's just pretend you were to add them up, you would get 0 equals 0. That's called an identity. If you watched the previous video, we ended the previous video with what's called a contradiction. But this being an identity, you would say there's an infinite number of solutions. Now that's where Algebra 2 ends, is when you get to this point and you say, oh, there's an infinite number of solutions because this is always true. But where college algebra picks up is, if you have an identity like this, then you do know you have an infinite number of solutions. But I want to be able to write what the solutions look like. Well, since these two equations, when you added them up, became 0 equals 0, which means these two equations are the same equations. You can easily see it. The top equation is just -1 times the bottom equation. So they're the same equation. So you'll grab one of those equations. I'll just grab the bottom one because it's cleaner. And you'll solve for one of the variables. It actually doesn't matter which one. I'm just going to go ahead and solve it for x. So you get 2x is equal to 2 minus 3y, or in other words, x is equal to 1 minus 3 halves y. That's what my x value is. And now I want to find out what not my y value is, because unfortunately I can't do it. I have an equation involving x's and y's, but at least I can find out what z is based upon this. So I'll go to any of my previous equations. Honestly, any of them except for the top one that doesn't have an x involved. So I'll go to this third equation right here, and I'll substitute that value in for x to find out what z is. All right, so I'll go ahead into that equation right there. I'll substitute in the value of x that we just got. We arrived at a negative, or sorry, we didn't arrive at, but the value is negative, and then we arrived at x equals 1 minus 3 halves y. And then we have minus 2y, and we have plus z is equal to -1. Now let me just tell you, when I have this equation right here and I say, oh, so 2x plus 3y is equal to 2, therefore x is equal to 1 minus 3 halves y. From that point forward, y is considered to be the kind of the free roaming variable, the variable that we're going to write everything in terms of. And so x is written in terms of y. I now want to write z, this value of z right here, in terms of this y. Let's go ahead and do that. I'll distribute this negative here to each of these factors, or each of these terms, sorry. That'd be a -1 plus 3 halves y minus 2y plus z is equal to a -1. I'll add 1 to both sides, which means the negative ones disappear. And 3 halves y minus 2y is a -1/2 y. And again, I'm going to solve this for z, so I'm going to add 1/2 y to both sides. So now I have x and z written in terms of y. Y is allowed to be whatever I want it to be, because y is just equal to y. And so one way you can write your solution to this system that has an infinite number of solutions, one way you could write the solution is as an ordered triple. The x value is 1 minus 3 halves y. The y value is y. And the z value is 1/2 y. And now, whatever somebody wants y to be will create a solution. If y were 0, we'd get 1, 0, 0. If y were 2, we'd get, what is that? -2, 2, 1. If y were 10, right, you could keep doing this all day long. You have an infinite number of solutions dependent upon whatever you choose y to be. Well, that's one way to write it. There's actually a lot of other ways you can write this, but I'm going to start by saying that most authors will not like it if you leave it like this. They would prefer that you use a parameter, and that's why we call this parameterizing solutions. Instead of calling that y, we're just going to say, well, let t be any real number. So let me just say that. Let t be an element of the real number system. Then, whatever we choose t to be, we could write this as 1 minus 3 halves t, comma, 1/2 t. I totally get what you're going to say. Aren't we just letting y equal t? The answer to that is yes. It's called a parameterization, and you're just essentially saying, I don't want to use the variables in the problem. I want to use just an arbitrary number t. So it's a weirdness that we have done in mathematics for a long time. So just stick with the idea of t. If you're using an online homework system, they'll tell you what variable to use or what parameter to use. Another thing I want to mention here, and this is just an unfortunate case of when people use online homework systems, that online homework systems are coded to accept only certain specific answers. So if you're using an online homework system, it might say, write your answer in terms of the variable z. Well, that's not the way we solve this system. Our answer is correct, but there are a few other ways you could write this that are equivalent, just not the same as the answer that we got. Or they don't look the same and likely wouldn't be accepted as the same in an online homework system. So let's pretend that you're working with an online homework system and they say, solve this system. And you say, okay, so let's go ahead and restart the problem here. And you say, okay, I'm going to solve this system. But you notice that they say, by the way, if there are an infinite number of solutions, write it in the parameter of z. For example. So you want, if you have an infinite number of solutions, you want your answers to be written in terms of z. So if that's the case, if they tell me specifically in the end that they don't want, or they want your answers in terms of z if there's an infinite number of solutions, I would not kill off z. Okay? I would kill off any other variable other than z. And that's you would still, if there's a finite number of solutions, you'll still get the right solution no matter what. But if there's an infinite number of solutions, then you're guaranteed to answer in the form that they would want in an online homework system. It's a slight caveat and change to mathematics because of online homework systems, basically. So let's go ahead and decide to kill off a variable other than z. And an obviously nice variable to kill off here would be the variable x. So let's go ahead and kill off that variable x so that we have a couple of equations in just y and z. So killing off x, we're going to take row, I'm going to label my rows here, row 1, row 2, row 3. We're going to take row 2 and we're going to add it to twice row 3. So 2x plus a negative 2x, those will disappear. That's beautiful. And then 3y plus, remember, we're multiplying this by 2, so plus a negative 4y is a negative y. And again, 0z, because that's what this is, and we're adding it to twice this, so 0z plus 2z is 2z is equal to. And then finally, we have the number 2, and we're adding it to twice that negative 1, which is actually 0. That's kind of nice, isn't it? Okay, so we get down to that point right there. And if you want to solve for, they want your answers in z, you could immediately solve this. Y is equal to 2z if you want to. However, if you're using elimination, you probably wouldn't have thought about that. You instead would have said, okay, I've got an equation with y and z. Let's get another equation with y and z. So you look through all of your 3 equations and you notice, oh, this top equation has only y's and z's. So I'll grab that. So you grab that top equation and you put it against this, y minus 2z is equal to 0. And you notice, hey, if I add these up, it'll become an identity. So there must be infinite solutions. And remember, they said, let's just pretend, that if you are going to get infinite solutions, please write them in terms of z. Okay, fine. I will just grab one of these equations here and solve it for y. So y will be written in terms of z. So I'll just say this implies y is equal to 2z. So now I know what y is in terms of z. Z is just z. Okay. And then go to any equation involving x and substitute in whatever you need to find out what x is. So one equation that involves x is this guy right here. So I'll go ahead and use that equation. I have 2x plus 3y is equal to 2. However, y is equal to 2z. Remember, I want my answers in terms of just z's. And so this tells me that 2x is equal to 2 minus 6z. Or in other words, x is equal to 1 minus 3z. You box that up, and that would be your ordered triple. 1 minus 3z, 2z, and then z. If they said write your answer in terms of the parameter t, then fine. It's 1 minus 3t, 2t, and t. There you go. So that's the plan of attack. That's how I usually solve these, using elimination. However, to be honest with you, there'll be faster ways in the future. Now, I don't think one example is good enough, so let's go ahead and do another example here. And in this case, let's just pretend they say, solve this system, and in the end, write your answer. If there's an infinite number of solutions, write your answers in terms of z. Okay, great. So that tells me immediately I don't want to kill off z. So I'll kill off x's because they look kind of easy to kill off, I think. So let's see here. I will take the opposite of 2 times row 1. And actually, you know what? I'm going to do it kind of easier. I'll take the opposite of row 1 and add it to row 2. So opposite of row 1 and add it to row 2. And by the way, there's other ways to do this. I could have said row 1 minus row 2. I just didn't. So the opposite of row 1 added to row 2. So that'd be a negative x plus x. The x's are gone. It'd be a negative y plus 2y. That'd be a y. It'd be a negative negative z, which is a positive z, minus or plus a negative 3z. So z minus 3z is a negative 2z. And that should equal, again, opposite of 0 plus negative 3 is negative 3. And then I would say, okay, well, let me kill off another set of x's. So I'll do the opposite of, twice the opposite of row 1. So negative 2 times row 1. And I'll add that to row 3. And so if you do that mathematics, that'd be negative 2x plus 2x, they're gone. A negative 2y plus 3y, that's going to be a y. Let's see, a negative negative z, or I'm sorry, a negative 2 times a negative z, which is a positive 2z, minus 4z is a negative 2z. And then finally, a negative 2 times 0 is 0, plus a negative 3 is a negative 3. Now you should notice these two equations are identical, which means that you have an infinite number of solutions. But if you don't notice that, you could just say, okay, well then I'll combine up these two equations into a system. So I have y minus 2z is equal to a negative 3, or y minus 2z is equal to a negative 3. The whole point, actually, as you move through mathematics, is to notice things before you do things. Okay, so you should notice these are the same equations. It's probably a good idea that you do notice that. However, if you decide to not notice that and you say, I'm going to take row 1 and subtract off row 2, you will get 0 is equal to 0. That will tell you you have an infinite number of solutions, which tells you that you are going to have a parameterized solution. And they tell us, hey, if you got an infinite number of solutions, please write them in terms of z. In other words, I want x to be something with z's, and I want y to be something with z's. So I'll just grab this equation there, and I'll add 2z to both sides. I now have y written in terms of z. I know that z is just equal to z. And then I go to any equation involving x and substitute in y is equal to 2z minus 3. So I'll just go to this top equation here. I get x plus, again, y is 2z minus 3 minus z is equal to 0. Or in other words, x is equal to, let's see, 2z minus z is a z, but you're subtracting it from both sides, so you get negative z plus 3. X is equal to a negative z plus 3. So our ordered triple for this parameterized solution is a negative z plus 3, 2z minus 3, and z. And again, if your instructor or your online homework system requires you to write this in terms of t, you could just trade those z's out for t's. Negative t plus 3, 2t minus 3, and a t. There you go. Again, any value of t that you substitute in will give you a solution. For example, if you let t equal 0, just pretend, you get 3, negative 3, 0. If you go to the original system of equations, if you let x equal 3, y equal negative 3, and z equals 0, 3 plus a negative 3 plus 0 is 0. That should make sense. 3 minus 6 is negative 3. Minus 0 is still negative 3. 6 minus 9 would be negative 3. Minus 0 is a negative 3. And you could do this for any value of t that you want to substitute in to our parameterized solution. So if you let t equal 27, again, you would get something a point that would solve that 3 by 3 system. All right, so that's how you solve systems that have infinite numbers, an infinite number of solutions. These are consistent systems with dependent equations. So when you're solving a consistent system with dependent equations, you're going to get parameterized solutions like this. And I'll show you in the next video how to make your own systems, and both with single unique solutions and infinite solutions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.